How the ozone layer is damaged by daytime ionospheric heater operations, or why do jet airliners drop certain metals and not others? A scientific analysis, October 1st, 2018, researched and written by me, the HAARP report. Some very surprising and alarming results. You can stop this warfare on the environment peacefully and legally by following the instructions at the end. This presentation is probably very similar to top-secret briefings held at the Office of Naval Research 2 decades ago. Note, all this content comes from publicly available sources. I have had no contact with classified programs or personnel. Abstract. The D layer of the ionosphere is used by microwave weapons to manipulate the upper troposphere. The natural ionization of the D layer is not sufficient for microwave stimulation. To increase the ionization of the D layer, jet airliner exhaust contains specific low-work metals. The increased ionization of the D layer turns it into a weapon. The metals are chosen to become ionized with energy available in the D layer. The ozone layer is damaged by the jet exhaust particles. The ozone layer is below, in contact with the D layer. Every time the D layer is manipulated by microwaves, a hole is created in the ozone layer. Simple steps are disclosed to stop this program. The early ionosphere studies were only concerned with how radio waves bend to enable global communication. Virtually all of these signals were less than 100 megahertz. Now, megawatt microwave transmitters, several gigahertz, are used to steer the jet stream, especially over the Pacific Ocean. Non-secret, publicly disclosed ionospheric heaters never did tests with microwaves. They never measured the surface ultraviolet UV after altering the ionosphere. Why? Because they intended to weaponize the ionosphere using microwaves, and damage to the ozone layer was never a concern. You can see at this lower point here, the Gakona, Alaska HAARP, which is this picture, was using less than 10 megahertz. The ionosphere consists of several ionized regions as the atmosphere reaches out into space and becomes very thin. And different gases are ionized in different ways as the high energy ultraviolet hits them. The part we're interested in is the ionospheric layer, the D layer. It's the very bottom layer, and the ozone layer, which is from 25 to 30 kilometers in altitude. The red line shows the temperature, and it just so happens that the D layer exists at the warmest point in the upper stratosphere, with the ozone layer beneath. The D region only exists in the daytime. Here is an actual measured value of ozone concentration. You can see the ozone layer is uneven, constantly changing. The D layer of the ionosphere is the layer used for creating HAARP downbursts into the top of the jet stream. This is the warmest, most dense, and lowest conductive layer, which can absorb microwave energy. That is why it is used for weather control. The D layer sits on top of the ozone layer in close contact. Ozone is destroyed by free electrons and ions in the D layer. The ozone layer is a thin blanket that allows life to continue on planet Earth. If compressed to our pressure here at the surface, it would only be 2 or 3 millimeters thick, or a tenth of an inch. Ozone stops deadly ultraviolet B from 280 to 315 nanometer, just below the D layer. Ozone serves as a sort of global security blanket because it absorbs ultraviolet radiation emitted by the sun and prevents it from reaching the Earth's surface at full strength, where it would burn everything to a crisp and render life impossible. Even a small depletion of the ozone layer translates into dangerously high levels of ultraviolet radiation at ground level, which could damage plant and animal life. As is happening out in the Pacific, the plankton is being destroyed over and over and over, disrupting the food web of the Pacific and causing the starvation and marine mammal death. Ozone works in this way to capture extreme ultraviolet at the edge of space, 100 to 280 nanometer, very high energy, splits the oxygen molecule. A free oxygen atom combines with another molecule to make O3. Then ultraviolet B, 280 to 315 nanometer, lower energy ultraviolet, splits the ozone molecule, and then the free oxygen can repeat the process. The ozone O3 molecule is easily destroyed by free electrons, ions like nitric oxide, any particulates or common pollutants like water vapor or sulfur dioxide. In the 1960s, the US, Britain, France, and Soviet Union were planning to make a fleet of SST supersonic transport planes. But these planes would have flown through the lower part of the stratosphere where the ozone layer exists. One of the principal exhausts of the SSTs would have been water vapor, usually considered a harmless gas. But water vapor is so reactive, the ozone is so reactive that even water vapor would react with it, turning it back into oxygen. By 1971, Congress held a hearing, and a scientist told them that a multinational fleet of SSTs would in fact result in a depletion of the ozone layer of several percent. Another scientist who specialized in nitrous oxides, which are a major exhaust component of the SSTs, said that a full fleet of SSTs would deplete the ozone layer by at least 10% in only 2 years. This would be disastrous for life on Earth. As MacDonald pointed out, the whole history of evolution has been a battle with ultraviolet, and so far we've just barely won. So for economic reasons, the US Congress cut off all funds for SST development, thank goodness. Back then there was enough of a pro-human US government that they wanted to try to preserve the ozone layer. Of course, that's the opposite situation to the present. Ozone is very unstable, and contact with anything other than oxygen will break it down. Strong thunderstorms deplete the ozone layer by injecting jet exhaust particulates and other pollutants into the upper stratosphere. The ozone layer changes by time of day, season, rising and setting sun, and weather, especially high pressure in the stratosphere, which is what the ionospheric heater is used to create. Here's high pressure falling air. We can see it's a surface pressure map because it's a 1028 millibar, and the dotted line shows a minus 30 ozone. So there's ozone loss when you have falling air. Whereas here's a low pressure at the surface, 992, and here we have a plus 50, plus 40 ozone. The ozone increases when you have rising air. Why is that? As the D layer moves down, ozone disappears because the free ions, free electrons destroy the ozone. As the D layer moves up, the ozone layer gets thicker. So in 1939 in Calcutta, they gathered this data, and notice they only talk about the E region of the ionosphere because the D region didn't really exist before the jet age, and that's a big clue. A is the amount of ozone throughout the year. Ozone content, curve A. Curve B is the hour of early morning sunrise, or increase in the ionization due to ultraviolet. So we have higher ozone when you have a later sunrise, because as the sun strikes this D layer, or they called it the E layer back then, it destroys the ozone. So when the sun rose, the observed E region reflection was found to drop appreciably. And the best information I have found on the D layer and how the ionosphere works is this 1951 book, which spent about 20 years on the shelf at the Air Force Special Weapons Center Technical Library. And in 1951, none of this was classified, so we get real scientific data that hasn't been filtered and vetted. In the 1940s, before the jet age, the D layer was almost non-existent, as shown right here. And the neutropause is where the ionic charged atmosphere begins. So the ozone layer is confined under the neutropause. And again, here you can see the D layer didn't really exist in 1951. Very small at the bottom, but they show the E layer, and that's it. In 1951, scientists could not explain the existence of the D layer except for the ionization of sodium metal particles. So this is the main point of this video, is that O2, first ionization potential, was really huge, 103 nanometer. So extreme UV, that should say 103. So Wikipedia says that it's 121 nanometers, again extreme ultraviolet, ionizing nitric oxide. So if we go back to the 1951 book and just read what they say, it's the most revealing and meaningful. Region D, the most widely accepted theory of the production of the D region, is that it is caused by the ionization of oxygen 2 at the first ionization potential as suggested by Mitra. But A&E Vassi maintain that photon energy down to about 7 eV is strongly absorbed by air according to laboratory experiments. That's correct. That Mitra is talking about extreme UV reaching far down into the atmosphere, and it doesn't happen. 7 eV is strongly absorbed by air, and that as such it is impossible for the corresponding radiation to penetrate to the required levels. I agree. Hence they suggest that the operative mechanism may be photoionization of atomic sodium. The threshold energy is only 5.1 eV or 240 nanometer. The ionization rate for this process is, however, very low and cannot explain D region ionization. According to Nicolette, one should take into account the three following possibilities. Again, the oxygen 2 ionization, sporadic ionization of sodium, and then ionization of nitric oxide, which is 130 nanometer. And I love this last paragraph. It says, the suggestion is certainly more comprehensive than any of the others. However, in view of the uncertainties of the parameters involved, no pronouncement can be made on the comparative importance of these processes. So could they be right about extreme UV reaching far down into the atmosphere? According to NASA, all extreme UV is absorbed higher in the atmosphere from 80 kilometer to 250 kilometer. NASA says extreme UV does not reach below 80 kilometer. So what is the real reason for the ionization of the D layer? In 1951, Mitra said oxygen 2 or nitric oxide, but these are extreme UV. Vassi said in 1951 sodium ion 5.1 eV 243 nanometer. 1951 Nicolette oxygen. Wikipedia nowadays says it's nitric oxide at 121 nanometer. Extreme UV does not penetrate down into the D layer, especially the lower part of the D layer. Bingo, this is the only reasonable explanation for the low-level ionization. 243 nanometer definitely penetrates into the lower, well, it reaches the surface in some cases. Let's assume some extreme UV reaches the 80 kilometer mark, or altitude. That still leaves almost no ionization at 50 kilometer where the ozone layer cuts off and where the ionospheric heater weather weapons need it to be near the Earth. Just to review, the 1951 measurements showed almost no D layer at all. Let's assume some extreme UV does reach the 80 kilometer altitude. That still leaves almost no ionization at 40 K. With modern day metal nanoparticles added to the D layer by jet airliner exhaust, now the ionization curve looks like this, and that is now adequate for the ionospheric heaters to use as a weather weapon. And just one more drawing here. Extreme ultraviolet, this green band, is shown being totally absorbed by about 150 kilometers up. So this is the correct view here. And the mid ultraviolet, UVB, that's going to reach really down to the ozone layer. They're showing it about 50 kilometer. So the statement from Wikipedia is disinformation, since extreme UV is absorbed higher up. And I can prove Wikipedia is a disinfo source for other verifiable physics topics, so this description of the D layer is highly suspect. So it appears, and we know, the low work function metals are really responsible for the daytime formation of the D layer, especially the lower part of the D layer. What could those metals be, and where could they come from? Here's ionization potential of the elements taken from the Handbook of Chemistry and Physics. On the left we have the element names, atomic number, and then here under the 1 column is the first ionization potential. We already know, and it goes all the way to Z. Setting an arbitrary cutoff of 6 electron volts, 6 eV is 207 nanometers, which does reach pretty far down. For the first ionization potential, we get a list of metals that could be used to create and intensify the D layer in the daytime. So this is a list of metals that have first ionization potential less than 6. And we see some very familiar names. Now order the elements from lightest to heaviest so they can float more easily into the upper atmosphere. It gets more interesting. Lithium, sodium, aluminum, potassium, rubidium, strontium, cesium, indium, barium. Picking the elements that are lighter and cheaper gives us this list of metals that can create the lower part of the D layer. Lithium, sodium, aluminum, potassium, strontium, cesium, barium. This gives the list of metals which are probably in airliner jet fuel additives and are used to strengthen or weaponize the lower part of the D layer. Any of these metals sound familiar to the solar radiation management geoengineering crowd? We know for a fact aluminum, strontium, barium have been found falling from airplanes. So this is amazing. We have just found the scientific reasons for spraying specific nanometal particles from jet airliners to create a strongly ionized D layer and use it as a new microwave weather weapon. Any cheap metal with ionization potential lower than 6 eV can be used, like barium, which is very common in lubricant, oil, and fuel. In addition to solar radiation management, the metal ions migrate to the D layer, where they allow the ionospheric heaters to create hot toroidal bursts of downward air movement. The metals enable control of the jet stream by strengthening the lower part of the D layer. So how do they drive descending air all the way down to the jet stream? First, there are 2 methods of ionospheric heating which do not appear to be usable to create the HAARP downburst of man-made high pressure in the jet stream. First, using the ionospheric current sheets to heat a small point low in the atmosphere. Second, using magnetosonic and alpha waves from the F layer to impact the lower atmosphere. The ionospheric current sheet forms whenever the planet receives sunlight because of the charge density and the gradients and the magnetic field. So here on the equinox we see these rings just show where the current flows, and it's equinox, so north and south are equal. Between each pair of lines, about 10,000 amperes flows. So there's significant energy. And here in the summer, the height of summer, the northern hemisphere gets more of a current sheet. And again, these are 10,000 amps flowing between these lines. So here's a representation. Current sheet flows in the lower layers due to higher conductivity, more density, but it's still 100 kilometers and below. The current sheet flows in lower layers, so the ionospheric heater has to heat the lower atmosphere to create some kind of insulator channel, because heating the air actually, instead of creating a conductive channel, creates an insulating channel. So where does the conduction channel come from? This approach doesn't work. The current is too diffuse, meaning 1,000 miles across you have it might be 10,000 amps, but it's 1,000 miles wide. It doesn't work. The current is too diffuse, cannot control the conduction enough to heat a small area near the surface. How about magnetosonic and alpha waves from the F layer to drive air down into the lower atmosphere? These waves are totally dependent on magnetic field lines, like the magnetosphere out in space near the poles. These magnetic field lines are not concentrated near the surface where the hotspot target is located. Therefore, there's no way that these can propagate to the target area. So here is how the megawatt SBX-type microwave computer-controlled phased array can heat the D layer and drive a jet of air down into the top of the jet stream. The dashed lines are the D layer, and here we have the Earth, green, and SBX microwave beam coming from the big golf ball. And the microwave frequency of the SBX transmitter is selected for maximum heating of the majority ion population in the D layer. So they already know what is up there in the D layer, and they're going to tune the frequency to flip those dipoles back and forth efficiently, just like the water molecules in your microwave oven uses 2.45 gigahertz, because that's the resonant frequency of that dipole. This frequency can be adjusted to suit current conditions. If enough ionization is present, all the energy is absorbed in a small volume, causing explosive expansion. Computer-controlled phased array beam is steered electronically thousands of times a second. The computer-controlled phased array beam heats a circle to cause expanding gas to create a high-pressure jet at the center point when the ring collapses on itself. The gas expands rapidly, crashing together at the center. A side view shows the expanding toroid of gas. When it collides in the center, it shoots a jet of gas down, and it forms like a smoke ring toroid, which conserves energy on the way down. As it travels, it continues in this smoke ring fashion, delivering that energy into the top of the jet stream. So it travels, and it's conserving its energy. Now, while this is happening, what happens to the ozone layer when the toroid of gas is driving downward? Remember, the D layer is right above the ozone layer. A gigantic hole is punched through the ozone layer. The ozone hole expands due to turbulence and contamination from ions in the D layer. The ozone hole expands due to turbulence, and the ozone hole persists for an unknown time, probably expanding for hours due to the turbulence. So you have ultraviolet B, 280 nanometer to 350 nanometer, reaching the ground level. How long does the ozone hole persist? 1 to 3 days, depending on stratospheric winds. The killer ultraviolet B is now reaching the ground level, which should never ever happen. How long does the ozone hole persist? 7 to 10 days. Maybe then the ozone hole closes. But during that that ozone hole, ultraviolet B, has killed the plankton down to 200 feet deep or deeper. Amphibians, tide pools, insects, tree leaves, tender vegetation, all killed. Food chain disrupted in the ocean. Crop yields down 50%. Skin cancer, cataracts. So what happens if more ozone holes are created than can heal up in a given time period? That's the real question to deal with for these weather manipulators. UV damage is all over the planet but never measured or documented. Why? Frogs going extinct in all the equatorial zones. Scientists blame the chytrid skin fungus which suffocates the frog. But what if the skin fungus is a side effect of high ultraviolet B? Why no testing of UVB in equatorial zones? What other evidence points to ionospheric heaters disrupting the normal cycles of the global atmosphere? The quasi-biennial oscillation has broken its normal cycle for the first time in 60 years. What is the QBO? So this is an animation of the historical measurements of the quasi-biennial oscillation. Every 28 months you have a ring of east blowing air collapse down to the surface, and then on top of that a west blowing ring. So red is east blowing wind, and blue is a west blowing wind. And this has been a 28-month cycle going back since they started measuring in the 1950s. So what does NASA have to say about how this could possibly be disrupted? Because it points straight back to the ionospheric heaters.
I said 2 years, but it's not exactly 2 years. It's 28 months, about. And you can see there's variations in the. It's not a nice sinusoid type activity. In fact, you can see down low, the westerlies are much more dominant than the easterlies down low. Let's focus in on this period here. So let me blow that up. So here we have the nice easterlies coming down, and here were the westerlies coming down. But you can see all of a sudden the westerlies were broken by the appearance of this small scale easterlies. And if I actually showed a full diagram, you could see that the westerlies actually moved up. So that was, we'd never seen that since in our entire record from 1953 to the present. We had not seen the QBO move up like that, nor this anomalous just appearance of easterlies. And so what we could see was that in this particular year, there's a really strong equatorward and upward propagation into this region here. Okay, so these waves are moving up and into this region. Now remember I remarked in the last movie about the tilt of these waves. And actually the tilt of the waves tells you the direction the waves are propagating. They're normal Rossby waves that are propagating towards the equator. So that was an important clue. That's when we knew we made this map, it should show this kind of behavior, and that's exactly what it does. Notice that the biggest vectors here are right in this region also, okay? Those vectors actually deposit momentum. They deposited easterly momentum to make things easterly.
So to put this in terms of the ionospheric heaters, he's saying that from 15 north latitude to 40 north latitude, something is driving easterly energy towards the equator. And if you create a artificial high pressure, that creates a clockwise flow, which is blowing from the west on the north side and from the east next to the equator. So in other words, the Pacific ionospheric weather control pattern actually shows up here as an excess of easterly flow pushing downward and into the equator. So they are abusing the ionosphere and the Pacific Ocean so much that it disrupted a global cycle that has gone on for probably many thousands of years. So in summary, the ionospheric heaters can control the jet stream but they cause severe damage to the ozone layer every time they operate. Ionospheric heaters tap into enough ionospheric energy to disturb the natural cycle of the quasi-biennial oscillation. Jet airliner exhaust is a multi-purpose weather weapon. Over 100,000 airliner flights every day with no regulation of nitrous oxides, soot, hydrocarbons, or metal nanoparticulates coming from the jet fuel additives. The D layer is mysterious and is secretly augmented by metallic nanoparticles for use as a weather control weapon. Stratospheric aerosol injection is used to hide global warming, to prevent us taking any meaningful action until it is too late. Metal nanoparticles in jet exhaust break down the ozone even without ionospheric heater operation. Metal nanoparticles in jet exhaust increase the ionization in the D layer, as the whole video is about that. A well-ionized D layer allows microwave jet stream control, leading to drought, fires, floods, and huge profits from weather futures contracts. What can you do in a peaceful, legal manner with non-violent non-compliance? If you want to stop stratospheric aerosol injection, chemtrail poisons, global death by ozone destruction, and ionospheric heater control of the weather, you must stop flying. Cutting the number of flights by refusing to fly is our only real control and our best chance to end the weather warfare programs. Scientists who understand the climate crisis already refuse to fly. Boats are okay, ground transport is okay, because they're not putting these things right into the part of the atmosphere that matters the most. If you fly, you are part of the problem, not part of the solution. Don't like chemtrails? Then stop flying. Don't like chemtrails? Don't like a dying planet? We humans do not consent to the killing of our planet. Show your power and stop flying. Last word. The damage to the ozone layer and the rapidly dying coral reefs, forests, amphibians, insects, etc. show the need for an immediate international treaty to ban the proliferation and use of this ionospheric heater technology. The human race is about to enter a nightmare world of petty rivalries played out by destroying the atmosphere. All the while, the people will be powerless to stop it or even understand what is being done to them. Like John F. Kennedy's 1963 nuclear test ban treaty, we need a 2020 atmospheric weaponization and ozone protection treaty. Without a treaty, our biosphere dies and we will disappear from this planet. Please do what you can while you still can, and thank you for watching.